Hey, how's it going, Algebra 2B people? So the video for this week, what you're going to notice is I'm skipping ahead to chapter 6. Because what I'm trying to do as we finish out the year from a distance is just kind of hit the topics that are easiest for me to teach on a video, and hopefully the easiest for you to do without having to have a lot of questions, since that's really kind of a difficult thing in this situation. Um, so I took you as far as I could in chapter 4 in teaching you the Pascal's triangle part, and then I taught you how to do synthetic division. When we get back to class together next year, which I hope happens, we'll take some of those ideas a little bit farther. Chapter 5 just wasn't a good chapter to teach from a distance, so we'll save that for next year too. So I'm going to move into parts of chapter 6, which I can do. Now today we're going to do 6.1, and we're going to focus on what's known as exponential growth only. Next week we'll focus on what's known as exponential decay, which is known as decrease. So here we go. What makes a problem exponential? Now we're going to be graphing. So we're going to make an XY chart, we're going to plot our points, we're going to draw our graph. They're all going to have a very common theme, and I'll talk about that as we go. I have 3 examples total, that's it, so this shouldn't be too long of a video. Now, every problem we do, including your assignment's going to be a worksheet again, and it's only going to be 4 questions for the whole week. It's not super demanding, you should be able to handle it. But here's how we're going to do this. Every chart we start, we're going to start by plugging the number 0 in the X column. Every problem we do, you'll notice there'll be a number. So y equals a number raised to the X power. So see, we choose those X's starting with 0. Now, we're going to choose in this lesson, we're going to start with the number 0, go to 1, go to 2, go to 3. We'll go as far as we need until one of our y answers gets close to 10. Now, that's my rule. You're going to say, well, where's that rule written down? I need a place for you to say, I stop here. Don't go, So once you get close to 10, sometimes you might get exactly 10, or you'll get past 10. That's kind of our stopping point, and I'll talk about that with the 3 examples we do. So here we go. Now, the first point's going to put you to the test. I'll remind you, but please remember, folks, anything to the 0 power is 1. If you check it on a calculator, 2 to the 0 power, 3 to the 0 power, 4 to the 0 power, a million to the 0 power, always 1. So if I plug that 0 right there, 2 to the 0 power is 1. Meaning the first point we'll put on the graph in a couple of minutes, 0, 1. We'll go to 1 next. Plug the 1 in. See, we pick x's, we put them right there in that exponent. So put that 1 right there. 2 to the first power is 2. Put a 2 in there. 2 to the second power is 4. Put a 3 in there. 2 to the third power is 8. So listen, we're getting close to 10, and without writing, and if we just were to check 4, 2 to the 4th power is 16. That's too far past 10 for me. Look, I got a small graph here, small boards to deal with. I'm not graphing that. And now we're not going to get into a huge detail, but we are going to select one negative number. And this is a discussion for if we were in class together to kind of go back and forth, but for the purposes of the video and our situation, I'm going to keep it simple. If you check 2 to the negative first power on a calculator, and by the way, if you're like at home saying, I don't have a calculator, your Chromebooks do have, you can have the Desmos, your phones all have a calculator. 2 to the negative 1 power is 0.5. And again, for the purposes of these videos, just do one negative number. Go 0, 1, 2, 3, 4, however far you got to go so you get a number close to 10 without going really past it, and then pick one, just do negative 1. Now, if I plot these points, every graph is going to have a common theme. So here we go, let's plot these. First of all, 0, 1 is up 1. not 1 right, up 1. 1, 2 is 1 to the right, 2 up. That's right there. Next point is 2 to the right, 4 up. So that's 1, 2, 3, 4, right there. And then the last point in the positive sense is 3, 8. That is right there. So see, guys, you can see how from the left to the right, these points are growing. And they're not growing in a straight line, they're curving, getting large quickly. The last point we're going to plot is negative 1.5. That's 1 to the left, half a unit up, that's little. Now again, if we were in class, I'd discuss that negative exponent, like 2 to the negative 1 as a half. I'd discuss that really carefully with you and get you to understand it. Like I said, we're just going to have to shortcut a few things and add those things to the list for next year. So, the graphs we draw, do not cross the x-axis. Now that's got a fancy name, which I'll say in the video. It's called asymptote. You do not cross the x-axis. It's a fancy thing. We'll speak of that later. So get right down here and just hover above it. And then this side takes off at a rapid pace. Knowing that the next point, had we graphed, it would have been 4 to the right, 16 up. That's quite high. So there's what these graphs will all look like. They'll all have this 6-1 exponential growth. They'll all look like this. Left side, hover above the x-axis. Right side, take off. Okay? Let's do that with this example. Now this example is going to have a different outcome. We got y equals 5 to the x instead of 2 to the x. I'll start with 0. Anything to the 0 power is 1, meaning 5 to the 0 power is 1. I'll go to 1 next. Remember, we choose the x's, we put them right there for the exponent. That's what makes them exponential. 5 to the first power. That's 5. Okay, now I'm going to write this down, but you're going to see something weird happen here, and we're like, wait a minute, but it will be okay. You put a second power in there. Put a 2 there. 5 to the second is 25. That's too big. We're supposed to get near 10. Well, guess what? 5 didn't quite get us there, and this is unreasonable. Now I'm going to cross that off my list. I'm going to leave it in my list, but that lets me know, like, hey, you know what? I tried to go there, but I got too big too fast, and we'll just settle with that. And the rule I want you to do, one negative exponent, just do negative 1. 5 to the negative 1 power will be 0.2. So we plot those. We're only going to have 3 this time. So 0, 1, 1, 5. Right there. And then negative 1.2. That's really close to the x-axis. I can hardly draw that. But see, it's got the same basic shape. Just come right down here and hover. And this takes off. And it takes off rapidly. That should be going up quite steeply. Remember, if I had room on this board, I would have gone 2 to the right, 25 up, which is way up here. So, there we go. Now, I'm going to give you a quick explanation. This negative exponent thing's bothering me. I don't want to leave you hanging. I know some of you will be like, I don't care. This is weird. I care. It's how I am. Negative exponents mean reciprocal of this number. Now, that's a fancy word. Reciprocal means take a fraction and flip it over. So remember the number 2. Think of it as 2 over 1. So if you flip it over, it's 1/2. So I'll just write that right here. Try to understand that 2 to the negative 1 power means 1/2 to the first power. See, negative exponent means take the reciprocal of this number, that's called the base, 2, and change the exponent to positive. So 1/2 to the first, and that's why 1/2 to the first is 0.5. Now the same thing happened over here. 5 to the negative 1, the reciprocal, 1/5 to the first. 1/5 is 0.2. 1 divided by 5 is 0.2. So technically that's 1/5, 0.2, and that's 1/2, 0.5. That's how that happens. So I guess that wasn't so bad to just say it, and if you're like, that just kind of blew my mind, let it blow your mind and just kind of go with it, okay? I'm going to pause a minute so I can do one more final example on this board. I need to erase a second. Okay, here we go, folks. Last example for this. And you're going to see a lot of similarities. That nothing's going to be that crazy different. Now, the only difference, though, that I did, the equation's got a decimal, 3.8 to the x. Please don't let that bother you, okay? Like I said, use the calculator. Use the calculator in your Chromebook. Desmos is one I hear a lot of people use. I don't personally use it because I got my calculator at home with me. But I'm going to need it for this question because I don't know things like 3.8 to the second power or third power, -1 power, because it's weird decimals. However, the one thing I do know, anything to the 0 power is still 1. Even, if you don't believe me, there we go. 3.8 to the 0 power. Look at that. 3.8 to the 0 power, 1. Okay? So anything to the 0 power is 1. If I take it to the first power, I know that too. 3.8 to the first power is 3.8. If I go to the second power, see now that I don't know. 3.8 to the second power, 14.44. I'll write 14.4. Now, you know that I'm not going to graph that because that's too big, but I'm going to just kind of keep it on my chart and cross it off because I have to think about this when I graph in a second. The last one I got to do is, I said always do your -1. 3.8 to the -1 is 0.26. We'll call that 0.26 or 0.3. I'll call it 0.26 just because it sounds better. Now, we're going to graph these. So 0, 1, right there where it always is. 1, now 3.8. So here's 1, 2, 3 we just approximate it. It's close to 4. But please remember, if I had room, like I labeled this up till 9, 2, 14, that's going to be up there. So I'm going to make this pretty steep. And then -1.26, that's really close here. So just like before, come down here, hover, and swing through here in a steep way. So, you guys, that's what you're going to be doing. You just got to do 4 problems for me. There's going to be 2 problems that were like the first 2 examples, like with whole numbers. And then there's going to be 2 problems like this decimal one. Just 4 questions total. Like I said, do them on the worksheet if you can print the worksheet. And if you can't, do it on paper. Like I'm kind of basically doing this on paper, drawing it as I go. You're more than welcome to do that. So that's going to be it for the next week. That's all I'm asking from you, and I hope you guys can handle that. Remember, send questions, and I will, if there's enough questions, I'll make a video of the answer sheet besides just posting an answer key. All right? Take care of yourselves. Be healthy.